Lesson 8709, Use Your Powers, Applications of Arithmetic with Powers of 10. In this lesson, we'll apply what you've learned about powers of 10 to answer questions about real-world situations. All right, we're on page 141 in your notebook, and our goal is, like we said, to apply what we've learned about powers of 10. Oops, that's a B. To answer questions about real-world situations. To answer questions about real-world situations. Okay, so we've talked a lot about powers of 10, and those powers of 10 and those exponent rules that we've talked about can be helpful when we're making calculations with really large and really small numbers. We're mostly going to be multiplying and dividing because those are the exponent rules that we really talked about. So this table shows the number of people in the United States in 2014, which is a really big number. We have 300 million people. And how much total oil they used for energy. Oh my gosh, that is even bigger. That is, looks like 2 trillion kilograms. So because these are such large numbers, it might be easier to write these numbers using a power of 10. So I'm just going to grab this number from the beginning and see how many powers of 10 that number is based on. So 1, 2, 3, 4, 5, 6, 7, 8. So a 10 with 8 zeros times 3 would get me that number. And let's also write this number with a power of 10. I'm just going to grab that first number there. And let's look at how many powers of 10 we've got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I took a 10 with 12 zeros after it and multiplied it by 2, I'd get this number. So I've written it using a power of 10. We're asked approximately how many kilograms of oil did the average person in the United States use in 2014? Well, they're really asking us about the kilograms of oil per person. So I'm going to think of that as a division problem. The kilograms of oil per person. So this bottom number is the number of kilograms I have. And this is how many people are in the United States. So if I'm looking for the kilograms per person, I'm going to be dividing those two. Now, this looks a little complicated. I know we've done problems like this. If you were dividing powers that had the same base, you would just subtract the exponents. I mean, we could expand this out to 12 factors of 10 and 8 factors of 10 and cancel some things off. But at this point, you know that we're just going to be subtracting those exponents. So if all there was to this problem was that, I'd be able to answer it. I'm going to leave a little bit of space here. That would be 10 to the 4th power. But I'm also dealing with this. Now I'm just going to leave, well, I guess we could do 2 divided by 3. 2 divided by 3 is going to be a repeating decimal. I should have written that in blue. So not only am I dealing with the powers of 10, but I'm going to be multiplying that by this division problem as well. 2 divided by 3. Now I'm going to go ahead and untangle this. And if I were to multiply a repeating 6, let's see, times 10 to the 4th power, that's a 1 with 4 zeros, I would wind up with about 6,666 kilograms of oil per person. Slid off the edge there. So if we're dividing, and it's not just powers of 10, then we're just going to divide the coefficients here and then multiplied it by the what we get when we divide those powers of 10. We can do multiplication as well. Let's take a look at this next section. The table shows the total number of creatures as well as the approximate masses of each creature. And we're asked, which is more massive? The total mass of all the humans on Earth or the total mass of all the ants? You know what? I think I am going to do some color coding here to help us keep track of what we're doing. So let's find the total mass of all humans. And we're going to need these numbers to do that. Well, for the total mass of all humans, the first thing I need is the total mass of one human. I'm guessing this is just an average. And this is in kilograms. 6 times 10 to the first power. That's one human. And I'm going to multiply that by the total number of humans there are. Now, luckily, they've written this as a power of 10. It's going to make my job a little easier. So this is really just a multiplication problem with 4 factors. 6 times 10 to the first power times 7.5 times 10 to the 9th power. And we know that when we multiply factors, it doesn't matter what order I multiply them in. So I'm going to multiply these numbers together. 6 times 7.5 gives me 45. And I'm going to multiply these numbers together using those properties of exponents that I know. When I multiply powers with the same base, I'm just going to add the exponents. 1 plus 9 is 10. So that's how much or how many kilograms all the humans weigh. Now I am going to go ahead and multiply that. You know what? Yeah, just so we can see how big that number is, let's show you what it is. But I might come back to this later. Just to see how big it is. This is 45 times a 1 with 10 zeros. 4, 5, 6, 7, 8, 9, 10. Wow. So it looks like, did I get those zeros right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So if I were to multiply 45 by 10,000, I would wind up with there's those zeros again. Make use of some commas. That is how much all the humans on Earth weigh. 450 billion kilos. Let's do the same thing with all the ants. I'm going to use purple for that because we're trying to figure out what weighs more, all the people or all the ants. A lot of ants in the world. So I'm going to do the same thing. I'm going to find the weight of one ant, and I can see from that negative exponent that ants are pretty light. And see, that's one ant. I'm going to multiply that by all the ants in the world. Looks like there's a lot more ants than there are people. I can tell that by looking at the power on the 10. And same thing. Doesn't matter what order I multiply these factors in, so I'm going to pull together that 3 and that 5. Trying to do this in purple. And I'm going to use what I know about powers of 10 to pull together these two powers of 10. I need to add the exponents. Negative 6 plus 16 is 10. So that is how much all the ants weigh. And just so we can see it out loud a little bit, it's going to be 15 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. And if I multiply those together, that's going to be 3, 4, 5, 6, 7, 8, 9, 10. 150 billion kilos for the ants. So people weigh more than ants. Put a big, this number is bigger than that number. And the last question that we're asked is about how many times more massive? How many times more is this than that? And I'm going to go back to this number when it's written as a power of 10 to ask myself, how many more times bigger is 45 times 10 to the 10th power than 15 times 10 to the 10th power? All right, well, if I'm looking at how many more times, then I'm going to divide these two numbers to see how many more times bigger, more heavy the humans are than the ants. So let's start with my humans. Back to my green. That was 45 times 10 to the 10th power. And then my ants, that was 15 times 10 to the 10th power. And just like I did before, I'm going to divide these two numbers, and I'm going to divide these two powers. Well, 45 divided by 15 is 3. And 10 to the 10th power divided by 10 to the 10th power, well, anything divided by itself is just 1. So humans total are 3 times as heavy as the ants are on Earth. So let's just finish up by saying, if you have two very large numbers, how can you tell which one is larger? Well, if they have the same power of 10, then I can just look at this coefficient of each of these expressions. And it's easy to see the 45 is bigger than 15. So if we can rewrite the numbers using the same power of 10, like we had right there, then the number with the larger first factor is the bigger one. And by first factor, I mean this 45 and this 15. Whichever one of those is bigger, that's the bigger number. It only works if you have the same power of 10. But it makes them a little easier to compare than all of these zeros that your eyes get lost in. So today we're just applying what we know about exponent rules to calculations that have powers of 10 in them. You'll see that we're using those multiplying powers with the same base means we add the exponents, and dividing powers with the same base means we subtract the exponents. That's more like what we did up here. So enjoy practicing this in the practice assignment tonight.